I'm Josh with OXIT. I have had the unique ability to be working with LoRaWAN for about a decade. So I started my first project in LoRaWAN was in Nairobi, Kenya with the American Red Cross. Deployed a LoRaWAN network in the poorest place on the planet and got addicted to the technology and saw its power and just leaned in. So I've had an incredible journey through leveraging this technology. OXIT is an IoT engineering services company, so we help OEMs integrate LoRaWAN technology into their product line and help them be successful. So my journey today here is to talk about some of those lessons that I've learned through scaling up. I think they're very applicable to LoRaWAN, but they're somewhat uniquely applicable, I think, to most devices and the journey we go through. So as I said, given that, I'm going to quickly plug my company. So Mount Everest, if you were going to climb Mount Everest, you'd hire a tour guide that's climbed Mount Everest. And so one of the plays for us is we're focused on LoRaWAN. I've got 40 firmware engineers that help clients develop code and help get devices up and running on that. So, as you look at product development to scale, though, the quick and dirty, simple thought, though, bring someone who's got experience with the scale you're talking about, though. And that's not just me. I just think in general, if you're deploying millions of units, having someone who has the experience of deploying millions of units is very relevant. So outside of that, I've touched roughly 100 LoRaWAN projects, and it's been an incredible journey. I'm going to dive into it. So, scale. If you will, entertain me on a quick journey. You're baking bread for a bake sale. You're gonna get some ingredients out of the fridge, maybe something out of the kitchen. You got a blender, some tools there. You whip up some bread, take it down the road, and sell them. So what if we got to do 100,000 loaves? All right. We got to look at our ingredients, right? What's the design? What are we using there? We got to look at our equipment and our processes, right? How are we going to put all that together? Then we got to think about our deployment. So for me, when I think scale, I think about the design, I think about the processes and the equipment that we've got, and I think about deployment. So that's going to be the theme for me, is kind of touching on all three of those. So jumping into design, the first one is MCUs, thinking about our architecture, things of that nature. I'm not going to go super technical, but one of the interesting things I think a lot of engineers deploy when we're selecting our architecture is we forget that the components that we're using are coming from companies. And those companies kill off products. So let's take an example of Facebook, Google. Both had IoT ingestion platforms over the last decade, and both have been killed off, and those are behemoth companies. Would those have been bad technical decisions? I don't think so. They're big companies. They got the right solution. But we got to look beyond the technology. And I think a part of the engineer's job is to weave cohesively parts together to solve a problem and create value, but it goes beyond that. We need to actually think about the companies producing those products. Figure out what their roadmap is. Have they developed this technology before? Is it their first one? How long has that product been out? So looking at product lifecycle basic data is not enough anymore. I think we've really got to have that intimate relationship with our vendors, especially those critical components, things of that nature. So, when you think about an MCU or LoRaWAN in particular, right, there's several vendors that have that technology baked in. Is this the first time they've deployed that, or are they on their second, third iteration? Beyond that, though, looking at, is that company got a family, a footprint that they're going to maintain for me? Am I going to be able to grow with them? But it's interesting, too, to think about innovation within that same context, because the pace of innovation for the companies we work with directly impact our ability to scale. So if we're working with a company, and let's say we're using a part from a company who's innovating really quickly. Well, if every time they innovate, they kill off the previous product, that's going to be really hard to scale with that company. So I like to think about the tail of scale, right? So as we start to scale up, we're going to have problems. And if the problems are growing faster than we're scaling, we can't scale. So if you think about like if GCP had killed off IoT, your MCU had went end of life, and you're trying to scale up and build 200,000 units, you could be in trouble. And if that pile of that tail of problems is growing out of control, that's where we get into problems. And again, these aren't technical problems. These are political and understanding and having that intimate familiarity. And that's sort of the, kind of gets back to the experience, but it also gets down to building those relationships, talking to these vendors, and understanding, hey, how long's this product been out? Are you guys going to do a new product? What's on the roadmap? Ask those questions of your vendors. The next one for me is thinking about software. I think within the LoRaWAN component, or LoRaWAN factor, but outside of LoRaWAN, a lot of times firmware engineers are leveraging code that's already been wrote for them. Call it a stack, a LoRaWAN stack, something to that nature. Well, a LoRaWAN stack has a life cycle, just like a part does. But if you were to look on a traditional hardware tool, we can see how long that part's been out for, when's it going to go end of life. But we don't do that for our firmware team. We don't ask them, how long's that library been out for? Are they going to maintain it? Is there a new one coming out? Within the stack, too, you've got different vendors. ST's got a stack. The Semtech's got a stack. TTN's got a stack. Which stack do you want to use? All of these things come with really interesting pieces of them. But within LoRaWAN, if you guys are considering it, I would challenge you to ask and learn what the stack doesn't do, not what it does. The gaps there are immense, and they're unique. So where Wi-Fi and Bluetooth, how you connect with those devices is sort of standardized. Reason for that, Bluetooth, 2.4 gigahertz, works globally. Within LoRaWAN, we got different regional parameters. You've got to change those parameters for every single region. All that nuance is pushed onto you, the engineer, the developer, to figure out how to weave that into a system that works. So the question I would encourage you to ask is, what does the stack not do? Not what it does, because there's a lot more you can learn from those gaps than plays into it. And the last piece for me is just RF. When I look at what's going on today in the ecosystem, we're combining a lot of different radios to create solutions. So if you look at Semtech, they've got their LR1110. We've got GNS resolvers, Wi-Fi scanning, and a LoRaWAN transceiver for less than 10, 20, 30 cents more, or it costs about 30 cents more than just a LoRaWAN transceiver. So for 30 cents, you're getting a ton of value. How does that impact your product and how are you scaling? So how I weave that in for me is thinking about when I release this product, what's next on my own roadmap? Do I need Bluetooth capability? Because it's really inexpensive to add these additional radios to your design, which allow you to stay competitive in your field, but also can give you abilities to update your design if you run into failure modes and issues. Use that Bluetooth as a backup way of updating. So think about using multiple radios. It can really, keep you in the market for the long run, but also help you out there in solving some tough challenges. So, yeah. So the next one is production. I'll be pretty brief on this, but give you some context. For LoRaWAN in particular, the kind of three things for me to think about, but I'll start off with security. This is true with any technology, though. Security is really interesting. A lot of people think because I'm using something secure, my product is secure. And that could not be further from the truth. Security is giving your engineers the tools to lock the door, but it's their job to lock it. So I'll give this quick example, but if you've ever dealt with an actual combination lock and you've seen someone who's written the combination across there on the top. Well, the same is true in your hardware. Your engineers are lazy. They're going to make the device print out the combination every time because they don't want to remember what the join keys are. They're going to make the Wi-Fi join, if it was a Wi-Fi device, they make the same joining password over and over, right? And then we rush them to get the products to market, and we never slow down and say, hey, did you lock the door? So remember, security is not just about keeping, about having and using something that's secure. LoRaWAN is secure, but you can leave the door wide open if you make bad decisions. A couple of those bad decisions are printing out the keys on the serial console, making every device have the same key. So imagine 100,000 devices all have the same key. Putting the join identifiers on the QR code so that every device you ship out has the combo printed on it and has to stay on it because it's built into the serialization of the product. So we see these kind of reoccurring themes happen out there. Not a problem for 100 devices, a big problem when you have 100,000 and you start to run into issues. The next for me is talking through programming and the keys piece of it, but getting into the programming part of the keys. How are you going to program 100,000 devices? So a lot of people go, well, I'm going to order the chips already programmed. All right, well then what if you find a bug in production and are you gonna keep building? What are you gonna ship those parts back, wait for the new ones to come in already programmed? So one of the key things for us is to think about, every device in this building's got a bug in it, every single one of them. So how we approach scale is about being able to react to problems that we run into. So if we have the capability to update our production line, we can keep those devices and keep our assembly line running, and we can salvage a bad situation. But thinking about programming is an important, critical piece that I think a lot of people skip over, especially when you try and do 100,000 devices. But weaving that back into security, right? So a lot of times, though, we're looking so hard at the device to make sure it's secure, but then how do we play that into our factory? So we get the join keys emailed to us with a CSV. We'll have all the keys in the data there in an email. How secure is your inbox? Right, so we put all this pressure on the devices, but we don't think about our operations and how we're going to secure it. So look at production and security as well, and think about your operations and really how you weave that into cohesive security across your organization, not just at the device level. All these things are going to help you scale, because when you run into an issue where your devices are insecure and someone finds out, suddenly you're not scaling anymore, and you're calling in firms to help you figure out how to solve your PR nightmare. All right, last thing for me on the production realm is just thinking about how you're weaving that back into those vendors earlier. So component shortage, we dealt with all those issues of people not having parts and things of that nature. So again, getting back in your production, recognizing that these vendors picked which companies succeeded and failed. The sales guy you were talking to decided what company got parts and got to continue to make money. So if you're not building that relationship with that sales guy, that vendor, you could be putting your company in trouble. Don't treat that guy like, I know they're annoying because they call all the time and they want to stop by and sell you a part, but treat them with a little bit of respect and it'll go a long way. And I think a good way of doing that is just having a relationship, but being candid. Hey man, I can't meet with you every week, but I'm happy to talk once a quarter. And being candid, but having that relationship with those guys can go a long way to keeping your business scaling and running well, especially in that component shortage. All right, last thing here about deployment. Firmware over-the-air updates is big for me. I'm a big fan of being able to update a device in the field, especially here in the US. So if you're not thinking about firmware over-the-air updates as part of scaling up, I think you're missing the mark. I had a vendor who, a big energy company, put all these sensors out there to detect if the doors open and closed. They deployed hundreds of thousands of these sensors. Well, what they didn't test was if the wind blew at the right angle, how the door would just sit there and shudder, and that'd trigger the device to send a bunch of messages. Then they had to pay the bill to get those messages. But not only that, the device died earlier than they suspected. All of it solvable with a firmware update. Guess what? The device didn't support it. So you got to look at firmware updates as a way of being able to react to a bad situation and enable you to keep being in business and keep selling a device. And the last piece for me is LNSs. I'm a big fan of using LNSs that are service provided, the TTN, the EveryNets, the Senets. These guys have really good products. The two mistakes I see is LNSs running on the gateways. Try not to do that. You're actually creating more problems than you're solving. And if you think that you're not, I encourage you to at least look at the pros and cons. If you haven't looked at the pros and cons, you're not making an educated decision. You're making a I just know decision. And that's a bad place to be. I've fixed more companies' problems by moving the LNS off the gateway and up to the cloud than I can count. The next one, though, is thinking that you can just download the chirp stack and run a service, run your own service in the cloud. Yes, you can do it. Don't forget to pay yourself, though. That's a lesson my uncle taught me a long time ago, was to count my time as money, too. A lot of people go, oh, look, I can run the chirp stack for free. And then you got a problem on Thanksgiving. You going in to fix it? What are you going to do? Are you paying yourself that time? What's your time worth? The other piece of the problem is smaller companies that get a lot of scale and start growing quickly. The guy who knows how to run the chirp stack leaves. Then who runs it then? There's no documentation. We don't even know how to log into the server. So looking at that as risk assessment, use these guys to get you up and running and to get to the mass volumes. And then when you got the volumes, figure out how to squeeze the money out of it. But leveraging these guys can save your holidays, your weekends, but also help you scale and get up and running, because you don't know what you don't know. And those platforms really do struggle to scale if you don't know what you're doing. So that's me. Appreciate you guys' time. I've got my contact information there. If you scan that, it goes to my LinkedIn. And I appreciate it. Thank you, everyone.